Good afternoon, everybody. So let us start our lecture today. And as usual, so let us see our syllabus. So according to our syllabus, we are almost at the end of the semester. So we are in this week 14, right? This week we are supposed to discuss PNP and NP completeness. We will discuss this in our next lecture. Please do not miss our next lecture. Maybe it will be an interesting discussion. We will discuss. Okay, and then actually I'm a little bit behind, so dynamic programming I will continue today. So as we see that dynamic programming is a programming concept that actually checks all possible solutions and selects or picks the best solution. Okay, so in previous two lectures we discussed how to use dynamic algorithm for solving for finding nth one for nth Fibonacci number, right? And then later we discussed how to find longest common sequence. Okay, how to find longest common sequence, and then that's it. Maybe in our last lecture, actually due to technical issue, I could not maybe cover thoroughly. There was an interruption for longest common sequence, but I shared a video from the evening section. Please watch that video from the evening section, okay, if needed. Okay, it's easy. So okay, that is the concept is that we use. Let me do a quick. So if there is no match, for instance here what we do, for instance x is a string or a set of symbols or a set of characters, and y is a string or a set of characters or set of symbols, and we want to check whether there is a sequence between x and y. Y has a sequence in x. Sequence means, for instance, b and b and d and d. Okay, there is a sequence. This is not required to be consecutive. Even it said b c d a b c d like this. Okay, still it is a sequence. And we found that this in this one we will find that b, the sequence is b and d. Okay, even the sequence it will give me 1 second please, my computer is disturbing, it needs to restart. I don't restart. Why is my annotator? Okay, got it. It was it was in hiding place. Okay. From our last lecture we learned that, right? If there is, so here b and d, b and d, if there is it does not cross, then there is a sequence. If it crosses, then there is no sequence. What do we do if, for instance, here x and y, so xi is over here, a b d. Okay, so I No, should not include. So A, B, D, Z, and then Y is G, B, D. So if there is no match, for instance, this one, go last one, is easy to. So last one, if there is no max, okay, then what is that? There is no max. So then return max of C. This is a C, and then C of C I minus 1 J and C of I J minus 1. That means max of previous two adjacent cells. So this one, max of this one. So here A and G do not match. So this is a so this cell value will be max of this one and this one. So max of this and this is 0, right? Max of 0 and 0 equal to 0. Okay. And similarly, if there is no match, A and B, they do not match. So max of this and this is 0. And here A and D do not match, so max of 0 and 0. So it is 0. And here we don't need this one because there is no character over here. Okay, and for this one, B and G, they do not match. So max of this one and this one is 0. Easy, right? And here this matches. Then 1 plus C of I minus 1, J 1 minus 1. I of J minus 1, C of I minus 1, J minus 1 is this cell. Is the previous one diagonal cell. Okay, so this is maybe 2, 2, so this will be 1, 1. Okay, so if I equal to 2, then this will be, so this one plus 1. So in this one, whatever my value is this one, and plus 1, so then there will be 1. So that means B and B, they match. And go this way. Okay, so this is what I discussed. So if you do not catch it completely, please watch my recorded video from other sections I uploaded in here. And then today we will discuss another algorithm, another dynamic algorithm for matrix chain multiplication. Okay, so matrix chain multiplication, for instance, we know how to multiply two matrices, row by column, right? We matrices row by column, and then it gets a cell value in the third matrix or the resultant matrix, right? So, and then for matrix multiplication, there are some rules. Okay, the rules are that, for instance, if A1, A2 and A3 dot dot, there are some matrices. For instance, A1, A2, A3 are matrices. A1 can be multiplied with A2 if, okay, then if we know that the this one goes by, so this one goes by, if A1 for instance has P1, P0, P1, these are for instance dimension, P, say P or D, whatever you say. Okay, this is A. Okay, and if B matrix is like P1, P2, oh, so they said A2, not B. Let us say A2. So A2. So please give attention over here, okay? And if A3, you don't need to write, just follow me, please, okay? If A3 equal to P3, P2 and P3, these are dimension. You can say D or P, whatever you say, no problem. Okay, so we can multiply A1 and B1 if this column, row and column, right? Column of A2 equal to the row of column of A1, first matrix, equal to the column of this matrix, right? Row of this matrix, right? And similarly, A2 can be multiplied with A3 if this one equal to this two. Otherwise, we cannot multiply matrices. Okay, the chain matrix problem is that, For instance, if I have a set of matrices, okay, which is the, for instance, a1, a2 and a3. For instance, we can multiply at least two this way, a1 and a2 we can multiply, and the result can be multiplied with a3, right? And another way it can be a2 and a3 can be multiplied first, and the result can be multiplied with a1. Okay, ultimately they will give the same result, but the complexity will be different. Complexity means how many multiplication, total multiplication will be needed, will be different. Okay, for instance, let us see some examples. Okay, if my A1 matrix is 10 by 100 and A2 matrix is 100 by 5, that means 100 rows and 5 columns, right? And then A1 by A2 will be, A1 multiplied by A2 will be, how many multiplication we need? 10 times 100 times 5, right? So A1 is 10 by 100, so A1 dot A2 equal to 10 times 100 times 10 times 100 times 5. So this 100 and equal, so there will be 1, so that means 10 times 100 times 5 equal to how many? 5000. 5000 multiplication will be needed to complete this, to get this multiplied matrix. And then this matrix, when it will be multiplied by with A3, okay, so then this will give us, so this matrix will be, what is the dimension of this matrix will be? Multiplication needed, and dimension will be 10 times 5, right? 10 by 5 matrix, 10 rows and 5 column, right? And the 10 by 5 matrix, and when it is multiplied with A3, so 10 by 5 and then multiply A3 will be 5 by 50. So then total will be, the resultant matrix will be 10 by 50, but multiplication will needed 10 times 5 times 50. Then 10 times 5 times 50 equal to 2500. And the total multiplication will be needed, this 5000 plus 2500 equal to 7500. Scalar multiplication will be needed to get the resultant matrix. With one matrix, the matrix will be like something this, dimension will be this 10 by 50, but it will need total 7500 scalar multiplication. Everybody understand this, right? On the other hand, if we multiply A1 and A2 and A3 first, we can do that, right? So then A2, because A2 and A3 they have matching, so then the resultant matrix will be 10 by 5, 100 by 50, and then it will take 100 times 5 times 50 equal to 25,000 multiplication, scalar multiplication, for only just getting A2 times A3. And then when the resultant, this result will be multiplied with A1, then that will take 10 by 100 by 50. 10 by 100, 10 times 100 times 50 equal to another 50,000 multiplication. The total multiplication is needed over here 75,000 multiplication, scalar multiplication. So we will get exactly same result, okay, but the way we are multiplying, the order we are following, what? Okay, the order we are following, for instance here, due to different order, what we are getting, in one way we are getting, it is taking 7500 scalar multiplication, in another way it is taking 75,000. So which one is better? Which one will be efficient? this one, right? This one will take less time, less memory space, right? So why we should select this one? So we should select this one. We should go this way, right? Although it will give us same result, but we should not go this way. In order to develop efficient algorithm or efficient program, we will follow this way. We will multiply A1 with A2 first, then result will go with A3. Everyone understand, right? So the problem is that a matrix chain matrix multiplication problem, it states that I have given a set of matrices. So which is the best order to select the matrices that are multipliable, that gives us efficient and lowest number of multiplications? Okay. So this chain matrix chain multiplication problem, we will learn how which is the order we will need to select. We will select not the actual multiplicated table, the final matrix. We are not finding the final matrix, we are finding the way, how efficient way, right? So let us see. Okay, another thing is that why you need to do an efficient way. For instance, if I have a number of matrices are given. For instance, if I have given 4 matrices, A1, A2, A3 and A4. So there will be 5 possible ways for 4 matrices. What we can do, A1 and A2 multiplied, and the result A1 and A2 can be multiplied, and the result can be multiplied with A3, and the total result can be multiplied with A4. So then how many nodes we are getting? 1, 2, 3. If we draw a tree, 3 nodes, right? What we can go like this way, other way. For instance, A1 and A2 are multiplied. Okay, then you get 1 node, and A2 and A3 and A4 are multiplied, we get another result, and these 2 will be multiplied, we got this result. So you see that there are 3 nodes. If you draw a tree, multiplication tree, then for 3 nodes there are 5 different trees. There can be 5 different trees. That 5 different 5 possible ways of multiplication. For 4 nodes there will be 14 trees, that means 14 possible ways of multiplication. And the formula is this: for n node there will be 2n divided by n plus 1. Different multiplication format, different tree. That means by looking at this tree, right, we can see which one will be multiplied by which one is the order. This tree executed is like this one first, and then this one, and the result will be this one. So the formula, for instance, for 3 nodes, okay, so if you for n equal to 3, how can you see? 2n equal to 6 C3 divided by n plus 1 4, right? So that means 6 times 5 times 4 divided by factorial of 3 and times 4. 6 times 5 times 4. This is 5. It is shaking. Okay, 6 times 5 times 4. Okay, so then 4 will be cross out, 4 and factorial 3 equal to 6, and then equal to 5. So you can plug in 4 instead of 3, then you will see there will be 14 different trees.
It's on the side of the tree.
Huh?
Like the little L looking thing.
Yeah, this is coming from my
How is it just like it's just 3? Is it just 3 or is it something else?
I don't understand your question.
The denominator over there, is that 3 times 4 only on the far right?
This one?
Yeah, that's just 3 times 4.
No, factorial 3.
Oh, factorial 4?
Yeah, so 6c 3 equal to 6 times 5 times 4 divided by factorial 3.
Okay.
And then divided by 4 is over here. I skipped some lines. You can do it. This is mathematics. So for 4 nodes there will be 14 different multiplication. So should we try all 14 multiplication for 4 nodes and then select the best one? No. There is a dynamic algorithm. Okay, we will follow and we will get the best possible order, best order that will give us minimum number of multiplication. Okay, let us see that algorithm. Okay, so the algorithm over here, it says this is the formula. M we will maintain is memoization technique. We will follow a matrix. For instance, matrix is M. Okay, 2-dimensional matrix. Ij will be M of ik plus M of k plus 1j plus, okay, p I minus 1 times pk times pj for k between I to j. K equal to I less than j. Okay, so you don't need to memorize for this. Let us see the demo and then you will get this formula. Okay, we will be using this formula. This is the optimal formula which this is used. So here that means we are using a matrix. That means this matrix is, for instance, this C matrix. Okay, matrix may be C, and this is the formula we will be using. So let us show a demo, then you will understand this. Okay, so the book has different, so some book has different way, or some books has something, or ultimately the process is same, but in some books the figure is this one is displayed without a table. It's like a table but grids are not shown. Okay, so but if you understand the technique, you can follow either way. Okay, so let us do this demo, okay, with the table, with the matrices just we just saw. A1, A2 and A3 matrices. Let us think A1 has 10 by 100 rows and A2 is 10 by 100 by 5 and A3 is 5 by 50. Just we discussed, okay, a minute ago. Let us with the simple one we understand. Okay, the process is that we will maintain a matrix. Okay, let us say the matrix M. Okay, actually we need 2 matrices because I did not get enough room over here, so I put 2 matrices in one. I will show. So let us think that there are 2 matrices M and S. They are identical. Okay, I will show, you will understand. Give attention please. So we are trying to find which is the best combination that will give us minimum number of multiplication, right? This is our goal, right? Okay, so here, so how this table is drawn? The table is drawn as 1 2 3. There are 3 matrices, right? So number of matrices, take the column 1 2 3 and this one 1 2 3. Give the column number, row number, 3 rows and 3 columns. Okay, and So this is the 3 rows and 3 columns. Okay, straightforward. This is simple. 1, 2, and 3. And when we pick A1 matrix, only pick A1 matrix. Nothing is there is no multiplication yet, right? A1, whenever we have just pick a matrix, A1. It is not multiplied by nothing. So that means there is no multiplication needed. And when we pick B, A2, there is same thing, there is no multiplication needed. And when we even select A3, there is no multiplication needed. Straightforward, right? So we got the diagonal values, 0, 0, 0. Okay, up to this is straightforward, right? Then what we will go, we will fill out this remaining one side, this remaining, this one, this one, this one, these 3 cells. Okay, whenever we understand how to fill out this, then we will understand. If we understand with this problem with these 3 matrices, we will be able to, you will be able to get for 4 matrices, 5 matrices, 6 matrices. Okay, I posted the version of assignment. This assignment I will update it. Okay, if you downloaded it, please re-download it after tomorrow. Okay, I will make some changes. Okay, now let us see that. For instance, whenever for I and j equal to, for I, this one, it says this one, this part of the algorithm. We are coming to algorithm later. Okay, so for ij, mij equal to 0, for I equal to 1, 2, 3. Okay, mii equal to 0. This is mii. 1, 1, m1, 1 equal to 0, m2, 2 equal to 0, m3, 3 equal to 0. So this statement is done. So now m1, 2. We are going to find this cell value, m1, 2. Okay, m1, 2 equal to m1, 1. Okay, we know this m1, 1 equal to 0, right? We know this, it is m1, 1 equal to 0, plus m2, 2. We know this is 0, plus this is the formula, p0, p1, p2. p0 times p1 times p2. Some books says d1, d0. D means dimension. Okay, dimension or power. So d1, d0, d1 and d2. So this is p0. This is p0. Okay, and this is p1. Okay, and this is p1. And this is p2, this is p3. p3. This is p2, this is p2, this is p1, and this is p0. Okay, so this is the formula. I will write the complete formula. I showed the formula few minutes ago, and this is the formula. Okay, so here, so p0 times p1 times p2. So p0 is 10 times p1 is 100, p2 equal to p2 equal to 5, right? So then 10 times 100 times 5 equal to 5,000. This value goes 5,000 over here. Now do you understand how to calculate this one? We found this by this formula. Okay, I'm writing formula later, but for now, for instance, this one. So everybody is okay for this one. So by doing this, what do we get? We got a1 times a2. How many multiplication we need for a1 and a2? We saw that 5,000 multiplication is needed, right? To multiply these two, 5,000, a1 and a2, to multiply this one, we need 5,000 multiplication. I will discuss this one, what this mean by this later, okay? This is S. This is a part for the S. I'm filling up M first, M matrix first, okay? Now, M23. M23 equal to M22 plus M33 plus P1 times P2 times P3. So we know that this value is 0. We know that this value is 0, M22 is 0 and M33 is 0. So this value is 0, this value is 0, and this value we know from here, dimensions, right? P1, P2 and P3. This is the P1, this is P2 and this is P3. 100 times 5 times 50. 100 times 5 times 50. So this is 25,000. So this value will go M23, M2 and 3. This is 25,000. This value is over here. This is 25,000. This value is going here, and this value is going here. So everyone understand how to get this? If you understand, then that's easy. Otherwise, it will take you hours. It may take you hours after hours later for you if you want to go alone. So better give attention over here. Okay? Does anyone has any question? Okay. So by this, what we got? We got the multiplication times of scalar multiplication needed for A2 and A3 matrix multiplication. A2 and A3, 25,000. Okay. Now let us do. Now we need this one, right? M13. This cell is 13, right? So M13 equal to. Now let us use this formula. Okay, we got this one 1 2 and 2 3 from this formula. Now let us write a little bit description about the formula. Just let me show you. This one will be minimum of, for instance, that means we are taking 3 matrices, 1 2 and 3. Okay, matrices 1 2 and 3. So what we are doing, so we can take 2 ways, right? We saw that we can select A1 and we can multiply A2 and A3, and then we multiply that result by A1, or we can do multiply A1 and A2 first and then multiply the result by A3. So whatever is our goal, to select the minimum of this, right? Either this or this. So now, so this matrix A1 is P0 by P1, right? And this one A2 is P1 by P2, here, this is over here, and A3 is P2 by P3 dimensions. Okay, so this total, this one will give us dimension P1 by P3, right? So these two will be cross out, these two will be cross out, so then this will yield us P1 times P3 matrix, and then when we multiply this, so this one will be yielded. Okay, then what is the result will be P1 P0 times P3, right? Okay, no, sorry, the total multiplication will be needed P0 times P1 times P3. Total multiplication will be needed. Okay, and for this part, actually for this part equal to M of 1 1 for this one. A1 means 1 1. Okay, taking the single multiplication, and then these two M of 2 3. We see that we already have this M1 1 equal to 0. M2 3 we already got it, right? In the previous steps we already calculated this 2 3, and then P0 P1 and P3, we have this value P0 P1 P3, right? Okay, and then one side is this one, and other side is the one. When we multiply this by this, then what will be our matrix? So this and this will be multiplied with this, so this will be cross out, right? Oh sorry, P1 will be cross out, this one P1 and P1 will cross out, so then we will get over here, P0 by P2 and then P2 by P3 whenever we multiply this, and then total this will be total will be P0 times P2 times P3. You understand this? And then this one is P of 1 2, this one is P of 1 2, M of 1 2 plus M of 3 3. Whenever you find single, then the diagonal element. Okay, M 1 2, we have 1 2, right? We have 1 2 value is already calculated, and M 3 3, we already got this one initially value from my initial value, and then we know P0, P2 and P3. So then total will be minimum of this part will give us 75,000 and this part will give us 7,500. So which one is minimum? 7,500 is minimum, right? And I'm getting this from this side. We're getting this from this side, right? A1 and A2 multiplied first, and the result will be multiplied with A3, right? By A3, right? So this one is giving us yield as the minimum value. Everybody understand? So now do you understand that this one is giving us minimum value? What is that? So this value, this cell value will go over here. We calculated this one, right? A13 will be this value. So for us writing demonstration, it takes time, but when you write a program, it will be executed quickly, right? Okay, looping, through looping. Okay, and then if exist 2 4, for instance, if exist there is other elements, and then the formula is like this. I am going so on. And 1 4, I wrote this formula if you need it. Okay, I will upload this slide in the D12, okay, after the lecture. I didn't upload. If we find any mistake, we can correct it. So now at this point, does anyone has any question? So far we constructed the M matrix. Okay, now if we understand how to construct the M matrix, it's easy to understand S. Here it is, okay. Now let us see S. S has 0, 0 and 0 initially. This is okay, and now we need the second S value will be either S1 0 1 or 2 or 3. S will take the only 0 1. How many matrix? Maximum 3, right? One matrix is 3 matrix. So S will contain either 0 1 2 or 3, nothing else. Actually 0 1 or 2. Okay, for this one, look at that. When we multiply, when we got 5,000, from where did we get 5,000? From here, right? Right? So here when we got 5,000, okay, we have got 5,000, right? So then we see that A1 and A2, right? So ultimately, whenever we got 5,000, how many matrices we multiplied at this point to get this one? How many matrices we multiply? 2 or 3 at this point? 2, right? Only A1 and A2, right? Okay, so A1 and A2 we got this value, right? So over here, so this says over here A1 and A2, and we got the minimum value. Over here, what is the left side suffix? 1, right? Left side matrix is 1, right? A1. So then put 1 over here. It means whenever you multiply A1 and A2, put A1 on the left side. So here A1 on the left side, right? And put 1 value on the left side, just 1. So in the matrix, in order to demonstrate it, I put on the left. The S matrix will hold only value 1, not this text. Just to describe it, I just wrote this one. Is okay? So S matrix will hold 0, 0, 0 and it will hold 1. Everyone understands? How did you get 1? Now, when we got this one, say this one, what is the left side value? Suffix. Left side suffix value, left matrix 2, right? So then whenever we got 25,000, 2 on the left side, so this cell value will be 2. Understand? We say that over here 2, right? Okay, now whenever we got this one, from this one, right? We got this one, right? So then it says now this one at this point 1, 3. So now we need this value, right? 1, 3. So up to 1, 3, how many matrices are there? We are going to multiply at this point A1, A2 and A3, right? 3 matrices, right? So here when we got this value, look at this, whenever we got 7,500, right? So then how did it get 7,500? From this pair, right? A1 and A2, right? So here this means the 2 matrices will be on the left side. 2 matrices will be 2, then 2 will be on the left side. There are 2 matrices on the left side, right? Left side are first 2 matrices. The first 2 matrices will be 2 matrices on the left side. The 2 value will be here. And then we can show here, whenever we multiply 2 matrices, then the 1 will be in the left side. So the 1 will be left side and then 2 matrices will be left side. So definitely the middle will be A2, right? So then definitely the third matrix will be the right side. You understand this? So this way 2 value, 2 got over here. That means whenever we multiply 3 matrices, first 2 matrices will be left side. And whenever we get multiply 2 matrices, matrix 1 will be left side. Okay, and whenever we multiply matrix 2 and 1 and 2, then 1 will be left side. Whenever we multiply 2 and 3, 2 will be on the left side. You see that whenever we multiply 2 and 3, 2 will be on the left side. And other way, for instance, we cannot multiply 1, 2. We cannot multiply A2 by A1. Can we multiply A2 by A1? No. So this value we don't need to fill up. This value, this one, we don't need to fill up. So through this dynamic algorithm, okay, so this algorithm, so this is the formula, it will be checking all possible values. Loop will be checking, right? There will be loop running. I don't need to do anything. Loop will be continued and it will be checking all possible values, and this is the dynamic way. Through this, what we will get? We will get the order through in which we should multiply the matrices to minimize the number of scalar multiplications needed. We are not finding the actual multiplication over here. Once we get the order, then we can multiply. We know how to multiply 2 matrices. You can do a Google search, there are many formulas. The book, many formulas, algorithm, and program. That is called chain multiplication, matrix chain multiplication in dynamic algorithm. Now, does anyone has any question? Okay, this will be a possible test question. Okay, and there will be homework. If you downloaded the homework, please after tonight, please download it again. Okay, I will upload the updated homework. I will include a matrix multiplication problem. But before this, does anyone has any question? So whatever we got, that we got this one is the minimum number of multiplication needed. We got, and the order is 1, 2, and 3, right? 1 and 2, then 3. So in our previous discussion, we found that whenever we multiply 1 and 2 by 3, then we got minimum number of 7,500 scalar multiplication. This justifies our algorithm. Okay, now in some, so this is S. Okay, in the book it says min, but I put S and M together. Okay, if you like, then you can maintain another. Actually, in the program, in the algorithm, you will see that it is maintaining two matrices. One is M, and another is S. Another is S. M and S is maintaining. So if you have enough room, then you can maintain M and S separately. But what I did, I put for instance here, they maintain. So in the book, you may see that some books they in a book they do not put grid for this table, and then some books they put the table ups like this one. Some books or some algorithm you may find like this. Like this, they put for instance 1 2 3 4 1 2 3 4. Let me keep us 4. Okay, and then some books has like this. So diagonal element 1 1 no so the 1 2 3 4, or they put or some book has like this one 4 3 2 1. Okay, and then they said this one is 0. Instead of 0 they put dash. Okay, I put 0, right? So then they put this one. That means this is 4 4, this is 1 1, this is 1 1, this is 2 2, this is 3 3, this is 4 4. So whatever, however you like. Okay, you can draw your. Or some book may have like this 0 0 0 0, and then they come this way. Whatever you follow, that way. Actually, the corner one, this value will give us the final order. Okay. So this is the algorithm, and now let us see the complexity. Complexity, it will take n cube times, because there are 3 for loops, 1 2 and 3. Okay, for I equal to 1 to n, and for we are maintaining another variable k in between, I, j and k in between. So you see that the formula, this has I, j and k, this has I, j and k, 3 indices. So that means it will be continuing 3 looping. Okay, so that means the time complexity will be theta n cubed. And then, but memory space will take two matrices, right? One matrix will take m time n, right? Another matrix takes m time n. But we know, although we are keeping the matrix halfway, we are using halfway, and then another halfway we are keeping unused. But since like two times m times n, then 2 times n times n's equal to mn. If m equal to n, okay, then in the worst case there will be n squared, 2n squared. Big O of 2n squared equal to big O of n squared. The space will be needed for 2 matrices and time complexity will be needed for n3 cube. This is the formula we used. Does anyone has any question? Actually, dynamic programming has other complicated uses or other uses, beneficial uses. Okay, so if you take advanced algorithm course, you will see that there are many other algorithms that are not covered in this basic course. Another question maybe can be counting coins. For instance, how many possible ways can be to make $1 with that coin, with the coins we have in market? We have a penny, right? We have a nickel. We have dime, 25 cents, right? 50 cents, and maybe $1 itself. So there are maybe six kinds of coins we have, right, in market, in US market. How many? 6, right? Penny, nickel, dime, quarter, half a pound, and a pound, right? That's 6. So that with the 6 coins, 6 types of coin, what are the possible combinations that you can make $1? You can take $1, that's fine. Or you can take 100 cents, right? That means $1. You can take 50 for 50 cents and then another $1/2, and 51. Or you can take 4 quarters. You can take 10 dimes. You can take 20 nickels, right? You can take 19 nickels plus 5 pennies, right? There are many combinations. So for instance, what are the possible ways, how many possible ways to make $1 or 25 cents or this kind of problems can be solved with dynamic. Don't worry, we are not getting that much complicated. We have just a few more minutes. Oh, sorry, I need to discuss one more thing at least. Okay. I should have a check. Okay, another dynamic programming application is zero-on knapsack problem. Knapsack means a bag. For instance, you have a backpack. Zero-on backpack, and you have some items. Okay? For instance, you are traveling to your home country. There are some items, for instance, these are electronic items, or for instance, these items, if you take in your country, you can give as gift, or you can sell it, you can make some money. Okay, think about that whenever you travel. So you have limited, so there are maybe 5 items, okay, different items, and each item has its cost, or maybe weight. Each item has its weight, and each item has its profit. So the problem is that you are asked your choice, which of this item you should select to get maximum profit. Okay, with the limit of your bag weight. Maybe your bag has 15 pounds. Some of this item maybe 2 pounds, and then it has $5 profit, and it has maybe 1 pound, it has $10 profit. Okay, it has maybe 6 pounds, it has maybe $2 profit. So what is the best combination you will select that you can make maximum profit? That is the problem. Is called zero-on knapsack problem. One restriction is that either you select item or do not select. You cannot break an item. This is a cell phone. You cannot take half, like Mr. Bean. Okay, you cannot break it and take half. That you cannot damage it. Okay. So this is the problem of its popular problem. It is called zero-on knapsack problem. So you understand the problem? You cannot break or make a fraction of an item, okay, and you have a limit. You cannot cross that weight limit, or for your backpack, within your limit, you have to do take good decision, wise decision to make the maximum benefit. Okay, let me teach you the algorithm. So then once if you give attention for the next 15 minutes, okay, 10 minutes, then you will see that when you learn that, whenever you go to your home country, you can do this. you can purchase some items. Okay, you can do it international travel, for instance. You can do this. So the algorithm is that 0-1 knapsack algorithm problem. Even we can do a, for instance, we can do the naive way. For instance, we can do a binary selection. For instance, if you have items 1, 2, 3, 4, 5 items, right? You may select only one of these items, okay, and none of these, or you can select, if your weight permits, you can select all of these, right? Or you can select someone maybe 0, 0, 1, 1, 1. So there will be how many combination for this one? N to the power 2 to the power n, right? If you do this way, brute force way, so the naive way, it will give 2 to the power n combination, okay? But we will see the dynamic algorithm is much more better. Okay. So time is short. I'm just giving you the description. Okay. This is the formula we'll be using. This is the recursive function, recursive formula. So again, we will be, as I said, that one thing is that for all dynamic programs, either you will use max value or min value to get the optimum value. For maximum benefit, you will get max, right? Max function. Or to minimize cost, you will be using minimum function. So here the value is over here. So okay. So that, for instance, give me attention for 10 more minutes. Okay. This is the algorithm. You see the algorithm in the book. So let us just describe it, and then it is the running time of this algorithm. This is one for loop. This is another for loop. Okay. And then this is a separate for loop, and this is a separate for loop, and within for loop this is another for loop. No, this is not within this one. This is outside. So actually, big O of n times wn times. Okay, this is inside. So the complexity will be big O of n times w. W is the weight, and n is the number of items. So this algorithm will give us. So you see the one for loop within another for loop. This for loop is going, outer for loop is going n times, and inner for loop is going w times. The total will be big O w times n, right? Complexity. Okay, instead of 2 to the power n. So we have 10 more minutes. So please give us attention. Okay, let us think that there are 4 items. Okay, and we have maximum weight of 5 pounds. My backpack can carry 5 pounds. Okay, the items are given over here. The first value weight and second value benefit or profit. Okay, first value is weight is 2 pound, benefit is $3 or $300 or $3,000 or $1 million, whatever unit is. Okay, don't worry about unit. The second unit is weight is 3 unit and profit is 4 unit. Third one, weight is 4 unit and profit is 5 unit, and the last one, weight is 5 unit, benefit or profit is 6 unit. Okay, and which are the pair or which of the items we will select within the weight. I can be given weight 15 pound, I can be given 25 pounds, I can be given 10 pounds, 5 pounds, no matter. If I understand the process, formula, algorithm, then whatever my max weight limit I can apply. Okay, that is not a matter. Okay, now let us see how do we do this. So according to the algorithm, for instance, these I, the number of items. Okay, so if you do not take any item, what will be your profit? 0, right? So this is the weight. So this one is item. The right side goes 0, 1, 2, 3, 4 items, right? So start from 0. 0 to 4, and then weight is start from 0 and give 5. 5 is maximum pound, right? So 0 to 5. You understand? So now, first of all, how do we select this one? If there is weight is 0, is there any profit? Is there any item? No. So no weight, no item, right? And no item, no profit, no benefit. Okay, so this table, this table, two-dimensional table, the matrix, it is maintaining our benefit or weight or our profit. Okay, so for instance, this is B, not written over here. So this one is no item, no benefit, no item, no weight. Okay, so this is 0 for 0 is 0, 0 and 0. It's easy, right? This is the first part of the algorithm. Okay, now we will maintain this. We have these items 1, 2, 3, 4 items. Okay, and we will fill out part of this table. We are part of these tables are already filled out 0, 0, 0. Now we will complete this table. Once you complete the table, finally at the almost at the end, we will get our result. We will get our best selection. Please give attention for the next 6 minutes. Okay, then hopefully you will understand. Okay. So for here, so item 1 is how many pounds? Weight 2 pounds, right? And benefit is 3, right? So item 1, if item 1 you can select, we can only select item 1 at this point. Is weight will be 3 pounds, right? Before that, all will be 0. If item 1, if your weight is less than 3 pounds, you cannot select item 1. 0 means I am not selecting item 1. So that means since item 1 is weight is 2 pounds, right? Oh, sorry, its weight is 2 pounds, right? So until you go to 2, wait for 2. So this value will be 0, right? Because item 1 is greater than, weight is greater than 1 pound, right? This is the weight, 1 pound. This is 2 pound, 3 pound, okay. And item 1. So this is 1 is 0. At this point, if you are limit with 1 item and then weight is restricted with item 1, if you are given to choose item 1 and if you are restricted with 1 pound, then you cannot select item 1, right? Then nothing, you can select nothing. Okay, so this is the second one. So after this, whenever you select item 1, then what will be your benefit? 3, right? So before that, this is 0. You understand this? Why it is 3? Because when you select item 1, then weight will be 2. So at the column with weight 2, you put 3. 3 is this value, right? So we are making this table as benefit table. This is B, actually is missing over here. So this is B. This is B. Okay. So now what will be the remaining values? So if only one item is selected, right? If you are selected only one item, can this is there any more way that you will be getting more benefit? No. Only 3, right? So the remaining value will be 3. This will be 3, this will be 3, this will be 3. Okay. Since only one item is selected, the benefit or profit is same across the cells, no matter capacities, your maximum capacity. If your maximum capacity is 5 pound and if you select only one item, still your profit is 3. Right? You understand? Understanding beginning is important, otherwise you will not understand the next part. Okay, that is what over here. So up to this, all these 3, right? Okay. Because whenever you select only item 1, then maximum benefit will be 3, and benefit will start from item 2, weight 2, right? This one, that's 2. This start, okay? No matter. Did we understand this? Now whenever we going to select item 2, we have to go with previously selected item. So previously selected, we already selected 1, right? We have to go with that item. So item 1, whenever we item 2 select, let us go to the item 2 select 2. So item 2 is weight is 3, right? And benefit is 4, right? So on the 3 and 4, on that cell you put 4, right? Okay. On the 3, this is 3 weight and this is the benefit 4. So put about 4 over here. And the all previous value will be if you item 2 select item 2, then it's 3, right? So this 3 came from here. And this is 0 because, so actually this cell will go all the way 0. So this cell will go all the way 0. We'll see that. This cell will go 0, this cell will go 0. Okay. This is 3, this is 3. Like this. So you understand why did I put over here 4? 4 is the benefit when we select item 2, okay, at weight 3. Okay, so this side, this one and this one, we got 4. Do you understand? Okay. Now the next two values, whenever you are given to select item 1 and 2, total weight will be 3 and 5, right? 2 and plus 3, right? Total weight will be 2 and 3 units, right? 5 units, right? So 5 unit, and then the total benefit will be 3 plus 4, right? Okay, so whenever you recess to weight 5, then your benefit will be 7. Until that you cannot select 2 items. If your weight is less than 5, right, can you select both? No. Whenever you recess to item weight 5, 2 plus 3, 5, then only then you can have benefit 7, right? Until that your benefit is 4. 4 is the maximum of this one, right? So here this one, here this will be 7. This one will be 7. You see that? You understand? This one 7. Why it is 7? Because when you recess, can reach to weight 5, 2 plus 3, right? Then you can maximum benefit, you can get 3 plus 4, 7. And this 7 actually coming from where? These 3, previous 3. It started, this benefit 3 started from here, right? And this benefit 4 started here. And they will be applicable when you reach to your weight 5. Then this 3 plus 4 equal to 5. Before that, after you reach to weight 5, your benefit will be less than, will be 4. You see the 4 maximum each of this, right? So this is why it is 7. You understand 7? Why it is 7? Okay. So at this point 7, with 7, what is your weight? 5, right? 7 weight 5, and then what is your benefit? 7, right? Do you understand this? Okay, give me 2 or 3 more minutes, please. Let me finish it. Okay. And then whenever you are going to select item 3, okay, then item 3 weight is 4, right? And then its benefit is 5. So whenever you reach 4, okay, then you can select, you may select item 3 here, right? At this point you may select item 3. Otherwise this value will be previous values. So as I said, all of these values will go with previous values. So this will go 0, then this will go 0, 3, 3, and 4 will be 4 over here. and here at this point. Let us see what is happening here. So at this point, if we reach 4, weight 4, okay, then weight 4, how can I take, which item I can take? Either one, right? If you have weight equal to 4, right, you can take either 2 or 3 or 5 or 4, because you cannot take any 2, because 2, either any these 2 will go more than 4, right, or even more than 5. Okay, so here whenever you reach at 4, then what will be your benefit? 5, right? So at this point is 5. So this is reaching from, previously it was 0 over here, and now it is getting 5. Okay, now the question is that what value will be our, we already got this value is 0, 3, 4, and what is our value from here? We have a 2 more cells. Okay, now over here, whenever you reach at weight 5, so at this point you can select all items. So whenever at this point, you already have at this point all 3 items are selected, right? So but if all 3 items, which of this you can take to get maximum benefit? Or what will be your maximum benefit? You can take 5, right? This is your 5, your weight limit. So 5, and then 5 you can reach either only 2 plus 3. You take 1 and 2, and then that will give us a benefit 3 plus 4, 7. This is the benefit 7. So this benefit is previous benefit. We can actually nothing. We cannot select 3 items. Actually, it says it's coming previous value. That means at this point, you are not allowed to select item 3rd. Okay, 2 more steps already. And whenever we get 4th item, okay, the 4th item, its weight is 5, right? So no matter, we will decide at weight 5 here whether we can select item 4 or not. If I could select item 4, okay, then the item 4 has benefit 6, right? But am I able to select item 5, item 4? If I select item 4 only, then it will reach to its maximum capacity 5. Okay, and profit will be 7, right? On the other hand, I already have 2 items, item 1 and 2 are selected with benefit 7, more than 5. So then I should not go this. So the algorithm will not take this, means we are taking maximum value. So this 7 will be remain as is. Now the last minute and the last slide. Last slide will tell us which of the items we will select. By looking this table, whenever table is generated, okay. So 7, it will be compared with previous value. So they are same, right? And it is compared with previous value. They are same, right? And it will be compared with this value, right? Okay, this value. So that means, so then you see that there is a change from 3 to 7 over here. So whenever it changes 3 to 7, that means this 7 came with the previous value and the left value. This change came, this has happened due to the reason of this change from 3 to 4, okay, and over here this one. So that means this change came from here. Okay, that means we have to select item 1 and 2. Okay, the algorithm, it looks by looking that B matrix, we will get who is the combination to select. This is the way, okay. And okay, this is the conclusion for dynamic algorithm. And do you have any question? Anyone has any question? Okay, so if you have any question, then we can discuss in our next lecture. But please do not miss our next lecture. We will be discussing maybe something new paradigm in PNP completeness. Give me 1 more minute. Let me get attendance, please. Thank you so much.